So these are things that we've done in Chemistry 30 so far and are probably ready to be assessed on. So you could follow along on the assignment I gave you or just watch this video. It's really up to you. But we talked about the spontaneity rule and ladder building. So using kind of stuff in tables or experimental evidence to build these ladders, which ranks OAs in respect to RAs. But the big idea is that if my OA is above my RA, that's a spontaneous reaction. And if my OA is below my RA, that's a non-spontaneous reaction. Remember that OA, so oxidizing agents, are things that are reduced, so they gain electrons. And reducing agents are things that are oxidized, so they lose electrons. So when we look at this chart, these are OAs on the left, and then these are RAs down at the bottom there. My strongest OA is at the top on the left, and my strongest RAs are down at the bottom. So if we look at this table and we do want to complete it, maybe you can try to do this first, just kind of pause the video, try it on your own, and then come back to it. But I know that Y2 plus is not going to react with itself. So we're not going to have anything with these ones when they're actually dealing with the same OA and the same RA. But when I look at Y2 plus, it is above Z, so that will be a reaction. Y2 plus is also above W, so that'll be a reaction. And Y2 plus is also above X, so that will be a reaction as well. That's my strongest OA, and so it should have the most check marks. Z2 plus will be spontaneous with W and with X, but it will not be spontaneous with Y because it's below it. W2 plus will be spontaneous with X, however it won't with Y and Z because again it is below those RAs. And then finally X2 plus is below all of these RAs, so that will be non-spontaneous. So that's and there's some steps here, and really we need to follow these steps. So the first step is to group likes together. Sorry, I have a very fat crayon that I'm trying to do this with, so the writing is pretty difficult, but I am getting some better stuff that will make it easier. So number one is we group likes. So when I look at this reaction down here, so the things I'm going to group together, I'm going to group this CR2, CR2O7, 2 minus, with CR3 plus. So when I'm grouping likes together, I'm looking for things that are containing things that are not hydrogen or oxygen and that have similar atoms. So chromium here is similar between those two. I'm going to group that together. The other thing I'm going to group together is my C2H5OH, my ethanol, and my acetic acid, CH3COOH. Those are going to be grouped together as well. So my first step is to group likes. If you see a question like this in this form, just ignore the H plus and the H2O because those show up when you actually go about balancing it later on. So first I group likes. The second step, and I'll do this in a different color, is balance things that are not hydrogen or oxygen. So balance things that are not H or O. So down here, I'm going to balance that chromium. So I have 2 chromiums on the left. I want 2 on the right. That's how I'm balancing that chromium. In my bottom reaction, I have 2 carbons here, and I have 2 carbons on this side, so I don't need to do anything different. Everything else is H and O. So my second step is to balance things that are not H or O. The third step is to balance O, so balance oxygen, and I'm going to do that with H2O molecules. So I look down here, and now I'm looking at the oxygen. So in this first reaction, I have 7 oxygens here, but on the right-hand side, I have none. So in order to balance that, I need to add 7 H2Os, because that gives me the 7 oxygens on the right-hand side. In my bottom reaction, I have 1 oxygen on the left and 2 on the right. So I need to add 1 water molecule on the left-hand side because I need 1 oxygen on that side. Now I have 2 oxygens on the left and 2 on the right. So I balance oxygen with H2O. The fourth step is to balance H's with H+. So I use hydrogen ions now to balance the amount of hydrogen. So in this first reaction down here, I now have 14 H's on the right-hand side, but none on the left. So I need 14 H pluses. In the bottom one now, I have 2 plus 5 is 7 plus 1 is 8. And on the right-hand side, I have 4. So I need 4 H pluses on the right-hand side. So the fourth step is I balance H's with H+. So first I group likes, balance things that are not hydrogen or oxygen, balance oxygen with H2O, and then balance hydrogen with H+. The last step to get the half reactions now is to balance charge with electrons. So the only thing we're missing now to make them redox reaction are electrons. Now when I'm talking about charge, we do need to look at ions. So chromium here is a 3+ ion, and there's 2 of those. So that means that on the right-hand side there, I have 6 positive charge. On the left-hand side, I have 14 H pluses, so that's plus 14. And then this dichromate is -2, so this is 12 plus. So I need those charges to balance, and I can only add electrons. So I'm not going to touch this lower side, but on this 12 plus side, I am going to add 6 electrons, because now my total charge on the left-hand side is +6. So by adding those 6 electrons, I now have a +6 charge on both sides. That one's balanced. I balance the charge with electrons. In this bottom reaction, so my left-hand side, everything's neutral, my net charge is 0. And on the right-hand side, I only have these 4 hydrogens, so my charge here is 4+. I'm going to, again, not touch the lowest side, but I'm going to add 4 electrons on the right-hand side, so that my net charge is now 0 on that side. So by just grouping like things together, balancing things that are not hydrogen or oxygen, balancing oxygen with H2O, and then balancing hydrogen with H+, and then balancing the charge with electrons, we now have constructed 2 half reactions for this reaction that was up here. This top one has electrons as a reactant, so this is reduction. It is gaining electrons, so this is my reduction half reaction. This bottom one has electrons as a product, so it is losing electrons. That's oxidation. So when this question asks for the balanced oxidation half reaction, that would be this bottom reaction, and when I look at all the options, that would be A would be the answer. If I did want to fill in coefficients, so you see there's this unbalanced reaction here. Sometimes we might want to fill in the coefficients. Well, then I can go a step further. And just like we were doing in previous weeks, I need to balance electrons gained and lost. So I have 6 being gained, 4 being lost. I need to multiply them each by a certain number, so I have 12 being gained, 12 being lost. Cancel things that are on opposite sides, and then I can get the net redox reaction. So that's how we balance things by constructing half reactions. This method is used when we have both reactants and products. We've looked at using the 5-step rule to predict reactions. That is only when we have reactants. But in order to use this method, we need both reactants and products. Whenever we do these calculations, so we'll have a concentration of one thing. So we'll have our concentration of our titrant. We need to use the volume of that. So if I take my moles per liter of my titrant and I multiply it by the volume, that would give me my moles of my titrant. Once we're there, we can find our moles of our sample. That's now using the balanced equation and the mole ratio. And then finally, we can find our concentration of our sample. Sorry, moles per liter of our sample. That's a very small eraser. This is bigger. There we go. So we can find our moles per liter of our sample. And that's just by taking our concentration and dividing by the volume. Now, one thing we do need to do is we need multiple trials. So just like in when we did this in acid base, we do multiple trials so that we get a more accurate value. So we have all these different trials. So we want to know the difference that's been added in each. It's 25.52 minus 10.11. So I have 15.41 mils in the first one. And then I have 41.79 minus 26.5. I have 15.29 in the second, and then 15.95 minus 0.64, and then 15.31 in the third. If I add those together and divide by 3, and then I have my average volume. So 15.41 plus 15.29 plus 15.31 divided by 3 is 15.34 mils. So I have my average volume. The one thing we do want to be careful of is what is this chart actually telling us? So this is the volume of permanganate. So I have my volume of permanganate. I also have my concentration of permanganate. So that's my titrant. That's going to be the one that I start with. So I'm going to start with my 0.13 moles per liter of KMnO4. And I'm going to multiply it by its volume, so 15.34 mils. You notice I didn't really change the volume to liters. That's not really important for these titration questions because we're dealing with milliliters at the start and at the end. So that milli unit will cancel. But if I look at that first unit, I'm left with now my moles of permanganate. The next step, so if we go back to the top here, is to go from moles of my titrant to moles of my sample using the balanced equation. So the one that I have needs to go on the bottom. So my MnO4 minus goes down here. The one I'm trying to find, so my oxalic acid, goes up top. And so this ratio from my equation is 5/2. The last step then is to express my answer now as a concentration. And if we look at our units, we have moles here. I want to find moles per liter. So I need to divide by the volume. It's the same as multiplying by 1 over that volume. So I know I have 10 mils of oxalic acid, so I divide by that volume. Now milli cancels, and I'm left with units of moles on top and liters on the bottom. So I do that calculation of 0.13 times 15.34 times 5 divided by 2. So anything on the bottom is division, anything on the top is multiplication. And then divided by 10 gives me 0.49855, and then to 2 sig figs, that would be 0.50 moles per liter. So that's the other thing that you are working on. I will post in the Google Classroom some practice questions from your roadmap that you can work on. If you do have any questions about those, or even ones that you have already received, just throw it up in the Google Stream, take a picture, and then I will reply with a walkthrough and some more teaching on that specific question. Your assignment this week is going to be things that are very similar to these kind of 3 types of questions that we've done together as a bit of a review. And it will also allow us to kind of just get the ball going with kind of what this course is going to look like in the coming weeks.